everybody, welcome back to my channel. So today we are going to talk about how to implement queues using linked list. First of all, we are going to talk about what are data structures and algorithms. Data structures are a way where we organize and store data in a computer so that can be used efficiently afterward. And also, it should be managed in such a way that it can be used to produce meaningful information. And they define the layout and behavior of the data specific operations like insertion, deletion, searching and sorting. So there are two types of data structures and nonlinear data structures. For examples for linear data structures, there are arrays, links, stacks, queues, and many. And if we talk about nonlinear data structures, there are graphs, trees, and so next we'll talk about a queue. What is a queue? Queue is a linear data structure which follows the logic of first in and first out, which means basically FIFO logic. It means that the element which was entered first will be the element that will be removed first. In a queue, there is an element called head, which is known as the next processing unit. So there are some functions specific for queue. Enqueue. Enqueue means inserting an element into the queue. Then dequeue. Dequeue means removing elements from a queue. And peek. Peek means checking the first entered element. Then there is isEmpty function, which means to check whether the queue is empty, and the clear function. Clear function means we can use it to clear, means remove all the elements. As a real world example, we can talk about the queue in a bank. The person who came to the queue first is the first one to be removed from the queue. So according to the Java connection framework, so here in the diagram we can see that the queue is extended from a connection interface and it can be implemented using linked list, array dequeue and priority queue. So when we are implementing queues, we can use either linked list class or array dequeue class or priority queue class to implement a queue. As I mentioned before, we can use arrays to create queues, but when we need to add new elements to the queue, we cannot add them because array has a fixed size. So it won't be suitable to make an queue. So that's why we use linked list to implement queues. Now I'll show you how actually a queue works. All the new elements are added from here using enqueue. And the elements are removed from the front using dequeue. And also this here, it is called as the front. And here it is called as rear. And whenever a new element is entered to the queue, this rear is increased by 1. So if we think about when we add 4 here, the rear goes to this. So this is basically what happens in a queue. You should always remember that enqueue is used to add new elements from the end and dequeue is used to remove elements from the front. So next we'll talk about linked list. So linked list is also a data structure, and the elements in the linked list is called as nodes, are stored in a sequence. This node, so each node divides into two parts, data and link. So each node divides into two parts, data and link. Data is used to store the data, and the link is used to store the address or the reference of the next processing node. As linked lists do not store elements in contiguous memory locations, so it allows for efficient insertion and deletion of elements. And also each node has an index. It makes us easy to access any specific element. As we talked earlier, in a queue we can't access specific element. So here, if we think this is a node, there are two parts. This is the data part and this is the link part. So if we draw a linked list like this, where there are nodes, few nodes, right. So if we talk about multiple nodes like this, and if we add 7 as the data or the value, here we have 700, 100 or something, and 200. If this is the linked list, this is the linked list, and here it goes the next processing address. In here we insert the next processing element's address, which means 100, and here it's going to be 700. Likewise, the address or the reference of the next processing element is stored here. So now we'll talk about what are the advantages of linked list. So the main advantage of linked list is that it doesn't need contiguous memories, and it has the ability to extend the size of the queue. Unlike in arrays, we can extend the size of the queue according to the new elements we are entering. So now we'll move to the implementation of queue using linked list. First, I'll show you how to implement a queue using in a diagram. So if we take a linked list, first we need to enter. So first we need to insert elements from this side, like from this side using enqueue, from this side using add operation, and when we want to remove the elements, we can use remove or forward operation. You can see in the diagram, this satisfies the FIFO logic, which means first in, first out. So the first element which is entered inside the queue will be the first element to be removed from the queue. So if we add 10 to the queue, it will be stored in this node, and then if we want to add 20, it will be stored in here. And when we want to remove an element from the queue, it will remove this first element which we entered into the queue in the beginning. So I'll show you the implementation using a code. So the main thing we need to do when we are implementing a queue is to import the libraries that we want to create the queue. So as we know, we are creating the queue using linked list. We need the linked list library. So we are gonna import it. And since we are creating a queue, we need the queue library as well. And then we need to create an object for queue using linked list interface. So now we need to create an object to the queue using linked list class. So queue so it stores integer values. So you can use any name you want to name the queue. I'm going to use queue. Then new int list. And now we'll start adding the elements. So the name of the queue as I mentioned earlier, we are going to use add operation to add elements 10. So if we check the elements in the queue, we are gonna print the elements. So you can see 10 is added. Now we'll add the rest of the elements. I'm going to add 20, 30, 40. 30. And 20. So when we run the file, we can see that so when we run the file, we can see that here 10, 20, 34, the first so the first inserted element, the next second one, third, and the latest and the last one. So as I mentioned earlier, there are some operations we can use for list. So we are going to see what the peek function As I mentioned earlier, it is operation in linked list. So we are going to see what it does. So queue dot peak. I'm going to assign it to a variable int peak element. And now I'm gonna print it. Peak element. It should show us the first element. We'll see. Yeah. See? It shows the element which is processing next. Which means so another operation I talked about is contains, which means we can see whether the element we are entering is in the queue or not. So I'm gonna see queue dot contains. I'm gonna add the number. We'll add the number that is in the queue 30, and we are gonna print it. So we'll see what's the output is. So if 30 is in the queue, so we'll see whether a number which is not in the queue is what's the result we are gonna get. We are gonna add 90 or something. It should give us a false. Yeah. So now the elements in the queue is 10, 20, 30, 40. So now we are going to remove the elements. So queue dot remove dot we need to see the removed element. So here it removes the 10, which means it satisfies the FIFO logic. The first element we entered was the 10 and the first element we removed was 10. So now we'll remove 20 as well. It removes 20. As I mentioned earlier, there is an operation called clear which removes all the elements. So we are gonna see the clear element queue dot clear. So it should clear all the elements 30 and 40. So this will remove all the elements. And now if we check the queue, so now if we check the elements in the queue, there shouldn't be any elements. So I'm going to print the queue. So there are no elements. So that's the basic of the implementation using. That's the basic of the implementation of queue using linked list. Now I'm gonna show you a program. So here I have created a class. Here I have imported the queue library, linked list library, and the scanner for the inputs. And here I have created a class, and in the class I have created an object of queue using linked list, and I have coded some functions as well. The first one is the enqueue method, which means we are going to add elements, and the next one is dequeue, which means we are going to, if the queue is not empty, we are going to remove elements. And the third one for the printing, and yeah, that's it. And in the main function, we are going to create an object from the class and use it to perform the operations. So here we can see that here I have used a while loop for the operations. I'll explain it to you when I run the code. Here the switch case for the cases to run the operations. So if we run the file, queue to see whether there are any elements. So there are no elements. So we are going to add elements to the queue. 1. I'm going to add 50. Then and 50, 40. Oh, sorry. Now I'm going to add another 40 and another number of 860 and another number 80. So now we are going to print the queue to see whether the elements are entered, to see whether the elements are inserted. So here we can see the elements 50, 46, 80. And now we'll remove elements from the queue. We're gonna choose the option 2. So it gives us a result. The 50 is removed. It means the first element was removed. And if we again remove another one, 40 was removed. Now we'll print the queue. So 60 and 80 is remain. So this is the basic of the implementation. There are some other ways we can implement queues without using libraries or by scratch. So I hope you got the idea how to implement a queue using linked list. So that's it for today. Thank you for watching and stay tuned for the next video. And that's it for today. Thank you for watching and stay tuned for the next deep dive. Until then, stay safe.